So my name's Dustin Whittle. You've joined Performance Testing Crash Course. This talk's really going to be about how to load test applications, how to load test NGINX itself, and then how to understand application performance and the impact that has on the success of applications. So I want to keep it a little bit interactive. We're a bit condensed on time, but if you have questions, feel free to just ask. So again, my name's Dustin Whittle. Find out more about me, dustinwhittle.com, or follow me on Twitter at DustinWhittle. So today I work as a developer evangelist for a company called APPDYNAMICS. We do application performance management. Previous to that, I worked as a consultant and trainer at a company called Sensio Labs. And then I brought the Symphony framework to Yahoo a few years ago and rebuilt Delicious and Yahoo Answers. So I've scaled some high traffic applications in my past, and I've been in charge of a variety of different web projects. And these are just some tools that I've learned along the way. But why does performance matter? That's really the question. Microsoft found that Bing searches that were 2 seconds slower resulted in a 4.3% drop in revenue per user. When Mozilla shaved 2.2 seconds off their landing page experience, Firefox downloads increased 15.4%. So you got 30 million more downloads just because the page was slightly faster. But making Barack Obama's website 60% faster increased donation conversions by 14%. So he raised millions more dollars just because it was a little bit faster to donate on the site itself. But the best performance stat that I've come across so far, and this comes from the Velocity conference, is Amazon and Walmart increase revenue 1% for every 100 milliseconds they shave off the end user experience time. Which means that every one of the large tech companies treats performance as a feature, not as an afterthought, and they recognize that it has direct impact on their business's success. So whether it's Amazon, AOL, Yahoo, Mozilla, Shopzilla, they all understand that performance is important. And I think that everyone has recognized that, because the reality is you lose faith very quickly in an application when it starts to fail. So the question is, how fast is fast enough? So 0.1 seconds or 100 milliseconds feels instantaneous. It feels like you're flipping a page in a book. 1 second allows you to think seamlessly, but after 3 seconds, people start to drift, and after 10 seconds, people abandon sites completely. And I think everyone has experienced this if you've ever been in a slow checkout process on an e-commerce site. When you add something to your cart, everything's working well, you go to click checkout, and then it just waits for 5 or 10 seconds, you start to quickly lose faith. What should I do next? Is it working or is it not? Most engineers know to just wait it out. I think it's not just enough to talk about application performance and how to measure that, but I think the shining failure of the last few years is healthcare.gov, because it's not just about being fast, but it's also about being available. And this is the first time I've ever seen a president go on national TV and apologize for a broken website. So I think you need to really test ahead of time before you get to production. Otherwise, you can end up with a very bad scenario. And that really comes down to the core idea of treat performance as a feature. So if you don't have your own application to test, here's a Spring app that's readily available to load test against. So it's Cloud Foundry samples /hello-spring-cloud. You can download it on GitHub and follow along, or you can download the slides later. They're already on speaker deck. So pretty straightforward. Just git clone the project, Maven package, and deploy it locally or push it to any one of your favorite clouds. But this is running right now on spring1-demo.cfapps.io. So it's just a simple demo app. Looks like this. Pretty straightforward. Very simple. So the question is, how do you actually evaluate performance? How do you run load tests? When you have really large applications, how do you run distributed load tests? And then more importantly, how do you actually test application functionality? Because it's not just enough to test the homepage. You actually need to log in, add something to a cart, go through a checkout process, and understand the application performance of every different business transaction or controller in action, however you decide the logical structure is. The performance often doesn't really matter for the homepage because it's usually highly cached. I mean, it depends on the type of property, but usually a homepage is highly cached, and a checkout processor, you might be talking to a payment provider, a shipping provider, somebody to do anti-fraud, tax, et cetera. And you really need to understand when you're testing application performance what the end-to-end picture is like. It's not just enough to test the server side as well. It's also to understand how is it perceived in the user's eyes. So these are some tools that I found along the way. The first thing is to understand your baseline performance, because you're going to get performance out of NGINX on certain hardware. You're going to get performance with NGINX and Spring Framework or whatever your favorite framework is. So you need to understand where the bottlenecks are and what the overhead of your tool chain is. Every framework has some overhead, so you need to understand the relative trade-off. So understand your baseline performance. So what I like to do is really load test a static asset. So a static homepage is serving straight HTML in NGINX versus a hello world in your favorite framework or whatever framework you're using to test against versus an actual application controller. And to understand the benefit, to understand the baseline versus what the NGINX overhead is versus the application server's overhead and then any third-party dependencies. So this one's probably not popular at NGINX conference, but if you've ever installed Apache, and I'm sure more than one of us have migrated off of Apache to NGINX, Apache Bench is included. It's a great utility for load testing applications. It's really straightforward and really simple, so I think everyone's probably run this command at some point. But if you just need to get a quick idea of the application performance or the relative web server performance, you can use this to generate concurrent HTTP requests to your application server. So this is relatively straightforward. So AB, so Apache Bench with a concurrency of 1 for a time of 10 seconds to some URL endpoint. So in this case, just spring1-demo.cfapps.io. Feel free to thrash this machine. And what you'll get is a quick summary of application performance. So what's really interesting to see here is what your throughput is. So the concurrency level in this case is really low. It's purposely set to 1. And then the request per second. So what's the latency for each request? Because to evaluate scalability, it's really about when the latency starts to spike and the throughput starts to go, when throughput goes up and the latency increases. So we'll get into that a bit later. So again, with Apache Bench, it's relatively easy to just add more HTTP concurrent requests by just increasing -c, so the concurrency level. So in this case, Apache Bench with concurrency level of 10 for 10 seconds against this app. And that'll give you, again, a simple output that tells you the level of concurrency and the average response time. So we get 65 requests per second, and sadly, you can't see the average response time underneath, but it's something like 300 milliseconds. So what that says is this application can get 65 requests per second, basically, at 10 concurrent users. And you can do this against your basic application, so a static baseline, which is like just a regular HTML page being served by NGINX. And I recommend running this against your actual application server, so Hello World in Spring or Rails or Django or whatever your favorite framework is, and then running against the home page or a simple controller in your application itself, so you can understand the relative difference of each piece. So there's a bunch of different tools for this that I'm going to talk about. The next one's really Siege. Siege is my preferred way to load test applications from a Mac relatively easily. So you can port install Siege, apt-get install Siege on pretty much every platform, yum install Siege. But once it's installed, it's just as easy as Apache Bench to use, but it's way more powerful. So in this case, you can use Siege with a concurrency level of 10, just like we ran earlier in benchmark mode, which means there's no delay between spinning up requests, and for a time of 10 seconds. So again, this is relatively straightforward, and you get a similar output. And what this will tell you is the throughput and the level of concurrency. So I purposely set these really low, so you can just see some useful stats. But we'll crank them up in a bit. Siege is great for just load testing any application server running over HTTP or HTTPS. But the reality is, how do you actually discover the entire application's performance? So all of these are fine when you just want to load test a single endpoint, but that's rarely what you actually want to do. Most of the time you want to understand the performance of each different transaction. So I found a couple of ways to do this relatively easily. So the first piece is discovering all the URL endpoints. So if you're using something like Rails or Spring, it's pretty easy to have the router dump a list of URLs. But more often than not, what's better is to just crawl the site and emulate a search engine, discover all the publicly available URLs, and then you can create a very unique list of URL endpoints for that application. So in order to do that, the makers of Siege also released a product called sproxy, which is just a simple, transparent HTTP proxy. So we can use any utility, use sproxy as the HTTP proxy, and any URL gets passed through there will just get logged to a file. So it's a very easy way to browse the web and track every URL that you hit. So in order to start that, relatively straightforward, sproxy, and I just want to output the file to urls.txt. So you'll spin up sproxy, and then you have a local HTTP proxy running, and all it's going to do, the only purpose is to log all the URL endpoints of your application. From there, one of the best things that I found, and you can do this while logged in or logged out, it depends which your goal is, but is to use wget in recursive spider mode. So basically use wget to index the entire application, start at the home page, recursively crawl every URL, And then every one of those requests will be piped through sproxy, and at the end you have a list of all the URLs for your application. And then you can sort and make them unique, which is relatively straightforward. And that's exactly what we're doing here. So we're using wget in recursive mode with Spider, and we just specified the HTTP proxy that we turned on earlier by using sproxy-o. It's running on localhost 9001, and then I want to crawl some demo application. And then I want to have a unique list of the URLs at the end of it. And that's what I end up with. So I can go to my urls.txt file, and it looks a little bit like this. And each one of these is a unique business transaction for our application. So we have the static home page. We have some content pages like about, contact. We have a card page. We have a books landing page, a login, register, et cetera, et cetera. This is actually much longer, but it's all that fits on a slide. So the idea here is simply how to discover all the application endpoints, and then how do I run load test against each application endpoint. And oftentimes, the load test isn't just as simple as running Siege or Apache Bench across a single endpoint. I want to actually do something in the application. I want to log in, add something to a cart, go through some checkout process, and I want to understand on a complex interaction the relative performance of each transaction, and then the performance of the aggregate of these transactions. So that's what we're going to do. So here we can benchmark the traffic across all unique URLs with Siege. So what this is going to do is just take the list of URLs that we had earlier at 50 concurrent users, type in the, we're going to run Siege with a level of 50 concurrent users for 3 minutes, and we're just going to pass in the list of URLs that we had earlier. And all that's going to do is load test each URL. But that's not really that useful because it's just running what we did earlier across each URL, which is how am I going to load test each one of these endpoints. But it'll give you a rough idea of performance of the application. What you really oftentimes need to do is manually build these transactions. So if you're more of a visual person, Apache JMeter is quite powerful, but it's a horrible product with a ridiculous GUI that's great. So if you're more visual, you download Apache JMeter. You can do all of this with a GUI and just create test plans by basically drag and drop. The idea here is it's really powerful, but I just thought I would mention it. Being an engineer, I like to write code for everything. So what I'd like to talk about now is really multi-mechanize. Multi-mechanize is an open source framework for performance and load testing. And when you have complex interactions that you want to test against, usually what I do is write a multi-mechanize project for this so that I can actually script a complex scenario. So you can do this very simply. It's all in Python, so it's very easy to install. Pip install multi-mechanize, and you're good to go. And then you can run multimech-newproject and just bootstrap a new demo project. It's just going to generate a template for you. But what's really interesting here is the concept of a transaction. So the only thing that multi-mechanize really cares about is that you define a transaction. It doesn't care what happens in the transaction. All it's going to do is run that transaction at high levels of concurrency. So I can do something very simple, like import the Python requests library, which is simply an HTTP client for Python, and call request.get Acme demo app. So I'm going to make one HTTP request to my application server and read the response back. Pretty straightforward. This is essentially what we did earlier with Siege, and then I can run this in a loop. But more often than not, this is where you need to script something more complex. So multi-mechanize also comes with a browser so that you can manage state, because if you really want to test complex applications, you need to be able to actually log in, keep those set of cookies, do something else, have the cookies change, and actually manage the HTTP state. So it comes with a cookie jar. It can respect things like caching headers, and it can respect the robot's policy, et cetera. So it depends what you really need. But the multi-mechanize browser is quite useful. So what you see here is simply a transaction that's just going to fetch the home page, create a separate timer for that transaction, and then fetch the cart page and create a separate timer for that transaction. So we have mechanized browsers, turn off handling robots, create a start time, make a request using the browser to Acme demo app, read the response, create the end time, and then multi-mechanize also features custom timers, which is really useful when you want to graph the response times versus the concurrency for each one of these transactions. And you can do these, I mean, again, it's just code, so you can customize it however you want, and you can make it as complex or as simple as you want. And what this is going to give you, it also provides you, you can assert. So if you want to do some level of functional testing along the way, you can do that as well, or assert that content's actually valid. In this case, we're just going to do this for the home page and for the card page, and then we're going to run the project. But in order to do that, we need to provide some level of configuration. So all we're going to do is say, how long do I want to run this script? You can create as many of these projects as you want. All you're looking at is the config file for multi-mechanize when I actually want to pass this in. Sadly, there's a little bit missing. But basically the idea is there's a runtime. How long do I want to run the load test for? And then how long do I want to ramp up? So do I want to throw as much traffic as I can, or do I want to ramp it up over time? So in this case, I want to run it for 10 seconds, and I want to ramp it up the traffic over the first 5 seconds. And there's no cap on concurrency here. So they can run multimech-run, the demo project that we just created, that we just bootstrapped. And what you'll get from this is a nice graphical output. It'll give you, this is actually just a few of the graphs, but what it'll give you is the response time over concurrency for each one of these transactions. I'm just showing the home page, but there's graphs for every transaction that I define and for every one of the custom timers. So it's pretty easy to customize for a complex application. Now, most of the time, this will cover you for most applications. But the reality is, what happens when you need more than one machine? What happens when you need to generate traffic for a load balancer that has 1,000 app servers behind it, or a large deployment? So what happens when you need more than one machine? And then by a show of hands, like who lives in the cloud? Who can just turn on more instances as demand increases, right? So when you do that, how do you actually test one, how well that system's working? But when you exhaust Apache Bench because you can only run it on a single machine, or well, easily manually on a single machine, how can you scale it past that? So let's talk about the coolest open source project I found in a long time called beeswithmachineguns. So first, round of applause for this amazing logo. Anyone? Come on. All right. So the idea behind Bees with Machine Guns, first, it's written by the people at the Chicago Tribune. Second, it's the only open source project I know of that comes with a disclaimer that it's a felony to use this against any other website but your own, because technically it's a distributed DOS stack, right? DDoS stack. So the idea here is that it's a utility for arming mini bees to attack targets, where you're spinning up EC2 instances to load test web applications, right? So how can I spin up EC2 instances, run a load test in parallel using all the network throughput and all the requests from those machines? So if you need to throw 10,000 requests at a single machine, that's relatively easy. We need to throw 1 million concurrent requests, that's a little bit more difficult. You're not going to do that off your single MacBook on a Wi-Fi connection. So again, this is a Python project, so it's very easy to get started. Again, just pip install bees with machine guns. So it uses the Bodo library, which is an abstraction around Amazon Web Services S3, well, all their services. And the idea here is you just simply need to specify Amazon Web Services ID and secret. So they're nice enough to provide free accounts for a year. aws.amazon.com/free, sign up for some credentials, and then you can just spin up a load test very quickly. But the only thing you need to do to configure this is create this Bodo file and drop in your key and secret. So once you have that set up, it's really about spinning up an instance that you can load test against. So here, the first command is called bees up. And what I want to do is spin up 2 servers and a default security group in the US West 2B data center using this image, this AMI, and this SSH key and this username. So it sounds complex and convoluted, this command, but really it's just bees up -2 when you have everything configured. And the idea here is I just want to spin up 2 servers in the US West 2B data center and use them for load testing. And these guys have great commentary in the output of these commands. So you're going to connect to the Hive, attempt to call up 2 bees, and you're going to wait for the bees to load their machine guns. And then you're going to need a report. So you can run bees report to figure out how many instances are in the swarm, or how many EC2 instances are in the cluster that you want to load test against. So here we just have 2 instances spun up, but this could be 2 or this could be 2,000 relatively easily. So once you want to actually load test against an application, it's as simple as bees attack, number of requests, and the level of concurrency. So here I'm only using a level of concurrency of 50, which is nothing. But you can very easily crank this up to 5,000, 10,000, depending on the number of nodes you have. So what's going to happen? It's going to read 2 bees from the roster, connect to the Hive, assemble the bees. Each one of these 2 bees will fire 500 rounds, 25 at a time, so 50 concurrent requests. Until the offensive is complete. Once the offensive is complete, you get a dump of some basic statistics. So the number of requests per second that we can handle, so in this case 306, with an average latency of 163 milliseconds. And the mission assessment is the target crushed the bee offensive. So the idea is that the server survived, and the swarm is awaiting some new orders. But that's really easy to get around. Just throw some more concurrency there. Bees attack, let's throw 100,000 requests with a level of 1,000 concurrency and see what happens. So this is just some small instance running a Spring app with absolutely no production settings. So it's not going to do too well. So reading 2 bees from the hive, connecting to the hive, assembling the bees. Each of the 2 bees will fire 50,000 rounds, 500 at a time, until the offensive is complete. And then again, you get the requests per second. In this case, we're getting 502 requests per second, but the average response time's gone up to 360 milliseconds. The target crushed the bee offensive. So basically, we've succeeded. The problem is you can just keep going up and up until you find the peak for that machine or for that cluster. So when you need to generate hundreds of thousands of requests, this is a very easy way to do coordinated distributed load tests. Relatively straightforward. So if the machines are acting up, I just thought I would include this. No bees completed the mission. Apparently your bees are peace-loving hippies. That's what happens when there's problems. So again, cost scale linearly with demand in the cloud. So you want to tear these down when you're done using them. The nice thing is you only pay for an instance hour. So it's really easy to spin up 100 machines for 2 hours, load test something, and then tear them down. And you just call bees down to destroy the EC2 instances. Relatively easy. Any questions so far? All right.
We are using thumb for the load testing. You mentioned that. How does
Which one?
thumb?
Oh, yeah, exactly. I haven't mentioned it, but yeah, there's that. There's work. There's Thor if you need to test WebSockets. There's a bunch of different tools.
Yeah, but thumb also scales up to these kind of numbers are used on single cluster for more than 100,000 requests.
Yeah, and depending on the hardware and the network throughput, yeah, you can definitely get more than 10,000 requests out of a machine. That's not what I was trying to say. But when you need to do millions, I don't think someone's going to do that on like a low-end machine over LAN connection. You'll exhaust the network throughput before you exhaust the actual machine itself. But yeah, all these tools will vary. Mileage may vary. Yeah. So what about the client side? I know I'm talking to a room full of NGINX fans, but I think when you think about performance testing, oftentimes, especially modern applications, more latency comes from the client side than the server side. So the 100 or 200 milliseconds you're waiting for the server side to respond is nothing compared to the 2 seconds you're waiting for the client side to download some JavaScript CSS to build a DOM to make the page actually available and usable. So it's also important to be able to test the client-side performance. So I think most people are probably familiar with Google PageSpeed, but Google contributes a ton of resources towards making the web fast. And one of them is PageSpeed. And what it does is it's available in a few different forms, in case you don't know it. It allows you to analyze and optimize your website with PageSpeed to get web performance best practices, so client-side tips on how to improve performance. But there's an NGINX PageSpeed module. So if you're very lazy, which we'll get into later, you can just add this module. Instead of fixing this stuff at the build and deploy time, you can do it at runtime by just dropping in the NGINX PageSpeed module, and it'll automatically rewrite your CSS and JavaScript and optimize it and combine it. But it's not very effective. You should be doing this stuff at build and deploy time rather than leaving it for runtime. There's a use case for this, but just thought I'd mention it. What I like about this is they have it via a website, they have it via the NGINX extension, and more importantly, they also have an API available for it. So the website is relatively straightforward, developers.google.com/pagespeed, and you can just type in a URL and get some actionable advice. So I should minify JavaScript, I should minify CSS, all the common best practices. They also have it available as a Chrome developer tool. And again, my favorite is an API. So a lot of these tools, it's great when you have to do this once, but you should be doing this with every deployment. You should be doing all this with every commit. It should just be built into your continuous integration process so that when you add features, you understand how much that feature costs you in performance every request. You shouldn't just wait to do it before you go live. And I think a lot of people do this stuff once, right before they go live, and they just never think about it again until it's time to capacity plan something else. And I think you can prevent a lot of failures by just baking this into your existing process. You automate everything else, why wouldn't you do this? So another tool that I found is WBench. It gives you granular insights into how much time is being spent in the browser itself. So you can just gem install WBench. So it's obviously written in Ruby. Basically what it'll do is use the W3C navigation API, timing APIs, to give you an understanding of exactly what's happening in the browser. So how much time am I waiting for SSL negotiation, DNS lookups, all the things that you don't necessarily see over the wire, to give you a better understanding of what's happening in the browser. So it's really easy to run WBench and some URL. And what you get is a breakdown performance inside an actual Chrome browser. So this is my personal website running in Chrome. And you get a breakdown of navigation start time, how much time you're spending doing domain lookups, when the response was available, when the DOM was actually ready to be used, and when you can actually interact with the application itself. So just because my personal website responds in 10 milliseconds, the page still takes 500 milliseconds, actually 2 seconds here, to be usable, right? So you only see the 200 milliseconds on the server side. Most people don't actually instrument the end user, so they don't actually have a good perspective. The other thing that can change with this is if you're serving traffic from, if you're serving a global audience, is really what it comes down to. Because if my servers are only in the west coast of the US and I'm coming from Australia, there's additional network latency that you're never gonna pick up on the server side. So you should try to automate client-side performance testing with Grunt. I think that it makes it really easy to do. I mean, there's a bunch of tools that allow you to do this. Grunt's my current flavor. So if you haven't been paying attention for a long time, you should be using Bower for managing dependencies, Grunt for automation, Yeoman for bootstrapping a simple app. Most of the time, if you just use Yeoman, you have a bunch of best practices bootstrapped in, and then you can use Grunt for the automation. So if you're not familiar with Grunt, it's a JavaScript task runner. So it's just a node library that allows you to have a command line for running and managing tasks. So one of those tasks could be, I want to load test the site. Another one could be, I want to emulate a browser and do some client-side timings. But what's nice about Grunt is they have a massive community of add-ons and plugins, and one of those is the PageSpeed plugin. So you can just npm install Grunt PageSpeed, and then you can automate everything using the API I was talking about earlier. So yeah, so I think that's the easiest way. If you download these slides, there's a lot more notes inside the slides. If you actually want to follow like a step-by-step guide, there's only so much time. This is a 40-minute talk. But how many people understand exactly how, let me actually rephrase this. How many of you would say you work for a reputable web company or would call yourselves professionals? Anyone? All right, you're all here apparently. And then let's keep the hands up for how many people actually understand the performance of their website right now in production. How many of you are going to find out about a problem when somebody complains? Yeah, so there's still people in here not wanting to admit it, but yeah, exactly. Most people don't actually monitor the performance of their apps. It's relatively easy to do. I work for an application performance monitoring company, so I'm not here just to plug my company. I also like to roll the open source solution because ultimately I'm an engineer at heart and I usually just build this stuff all myself. So let's talk a little bit about how to do that. When you run load tests, and the reason I mention all of this is the whole idea of generating load and understanding that performance and hitting those high levels of concurrency is to break things or to see where you stress things out the most. And to be able to see that, you need to instrument everything underneath so that when you run your load test, you can actually get actionable advice from that or better intelligence. So you should track performance in development and production. But how do you do that? So you need to instrument everything. I think NGINX is pretty easy to monitor, but instrument your code, your databases, caches, queues, third-party services, and all of your infrastructure. Easier said than done. It's very easy to just measure if the website is available. I think everyone's suffered through Nagios at some point in their life just to measure availability. But oftentimes that's not enough. You want to understand exactly what's happening. Current open NGINX connections, how many database connections are open, what's the average response time for the PayPal API that I rely on or some third-party API, what's disk I/O, network I/O, et cetera. So when you're running load tests, you need to make sure you don't do that until you actually have instrumented this so that when you run the load test, you can actually see some data. So I'm a big fan of Chef and Sensu. Pick your flavor. You can pretty much do this with any tool. I'm just going to talk about this because it's near and dear to my heart. So Sensu is an open source monitoring framework that makes it very easy to monitor availability, but also more importantly, to gather stats from a machine. So if you want to be able to instrument NGINX, it's very easy to deploy with Chef a new instance of an app server, and an app server consists of a service that has these cookbooks, and that's NGINX, right? But on top of that, when you describe your service, you might as well describe how to collect metrics from that service at the same time. So if I'm using NGINX, NGINX has a way to collect status metrics, like current number of open connections. It's very easy to collect all of that information and then graph it out. So a winning combination that I've found is combining Sensu, StatsD, Graphite, and Grafana. So use Sensu and StatsD to collect the metrics, pass those metrics into Graphite to store them and graph them, and throw Grafana on there so you have a sexy dashboard. And ultimately, what that can look like is something like this. So this is just the Grafana dashboard, and you can collect any custom metric. There's hundreds of different services that you can pay for this sort of service. But the idea is that you should just instrument your infrastructure. So you can understand disk I/O, you can understand the average response time of various third-party services, you can understand cache hit miss ratio, all the things that when you're throwing a lot of load at a server, you're going to want to understand what the issue is underneath. So sometimes that's your 100% cache miss ratio. Sometimes that's this third-party service slows down or rate limits you after some level of concurrency. You don't really understand that until you actually instrument. So you should do that, and you should also track the performance of end users. Again, when you're serving a global audience, you really need to understand the relative perceived performance, right? It's not just how fast things respond on the web, but what are your users actually dealing with? So what's the end user's perceived performance? So there's a couple of libraries available. There's Episodes and Boomerang. I use Boomerang, and basically it's a JavaScript library for tracking client-side performance statistics. So there's a couple of different things that you can do with it very easily. The one I'm going to talk about is measuring a page's perceived performance. So what's the end user response time? At what point is the browser actually ready? And how does that differ in every region? So the way generally this works is you throw in some JavaScript into the end user experience. In this case, it's the Boomerang library, and then I can track some stats and beacon those off to something like statsd. So again, there's not only Boomerang, but there's Episodes, which the people that originally worked on PageSpeed, the people that originally wrote Why Slow at Yahoo, that's who wrote Episodes, and that's who wrote Boomerang. The idea here is that Episodes has a custom API so that you can add additional events. So if you want to track additional custom metrics on the client side, you can use Episodes to do that as well. So maybe I don't just want to track how much time I'm spending to get the response available, but I also want to find out how much time I'm spending waiting for jQuery or waiting for some animation or waiting for some other thing that I'm doing that's intensive in JavaScript. And Episodes allows you to do that very easily. And then there's webpagetest.org. So webpagetest.org is, if you're not familiar with it, it's a free service. It looks basically like this. The idea is that you can go to the site, drop in a URL, and then be able to see that site in a browser from a different location over some specific connection. So if I want to see my website running in Chrome from Sydney, Australia over a DSL connection, it's very easy to do that and to be able to get an idea of performance globally on demand. So synthetic monitoring with a lot of detail very easily. And what that looks like is you get a report that shows like this. And the idea here is that not only do they give you a screenshot, which can be useful for QA, but they give you really granular client-side performance metrics, and more importantly, the waterfall breakdown of where time is being spent. So webpagetest.org also has an API. So if you do a new deployment and you just want to understand how the performance has changed around the world, it's very easy to script this and be able to get these reports to your QA team in real time. So that's what I use this for, and I would highly recommend everyone do the same. Sitespeed.io is a little bit, it actually builds on a lot of these different tools, but the idea here is it's relatively easy to install. Brew install Sitespeed.io. And then you get the sitespeed.io command. And it's relatively easy. You just run sitespeed.io, missing a slide sadly. Sitespeed.io and then the domain name, and you can get a report that looks like this. And what it'll give you is client-side performance. So page score, number of DNS lookups, number of requests without gzip encoding. And basically the idea here is it gives you a client-side performance summary that you can use to build rules around and test against. So if at some point we add a request that's not gzip, like I want to know about that. I don't want to find out later when I manually go and test through my browser. And Sitespeed's a great way to do this. And then I mentioned AppDynamics, but there's AppDynamics, there's New Relic, there's CompuWare, there's AppNeta, there's Ruxit. There's 100 different companies out here that do application performance management. The idea here is not to use our software. It's that you can either build this yourself or you can buy this solution, but you should do some level of monitoring. And you should try to monitor not just your infrastructure, are things running, is the CPU load acceptable, but also what's the application perspective and the network perspective on this. And all these tools try to provide that. So obviously AppDynamics is the best. And what these tools generally do is they map out your application topology. And when you're running load tests, you can actually drill down to see, hey, why did a specific transaction fail? So you can get a full call graph. You can get visibility into client-side performance. So around the world, where's traffic coming from? And when we're having slow requests on the client side, you can get granular visibility into exactly what's going on, both on the server side and on the client side. And it gives you visibility into the app stack. So it's not necessarily just using our tool. It's about having some visibility into your application servers, into NGINX itself, into the operating system. And there's a bunch of different ways you can do that. I prefer the open source way because I'm an engineer and I'm also really cheap. I just use everything off the internet. And if you're willing to just put a lot of effort in, you can get the same thing eventually or something better close. Or you can just buy it in a box. And not only are there commercial tools like this, but there's a ton of commercial tools for generating load tests from the cloud. So I talked about a bunch of open source tools earlier that allow you to do this, but you can also buy it in a box. It's relatively easy to do. So let's talk about a couple of those. Apica is a cloud-based load testing solution and also synthetic monitoring solution. And the idea here is I can use their application, I can design a load test scenario, and then I can just say, run this load test scenario from all these different locations and give me a report. All these services basically do that piece. There's Blitz.io. If you just need something quick and dirty, and you just want to generate 50,000 concurrent requests to a website, you can really easily use Blitz.io, sign up for a free account, and throw some traffic at your application and get a fancy report. I like Blitz.io for simple tests, and I like Apica for like complex interactions, especially when I need to run load tests from Australia and Japan and from different locations. And I need to do it at high levels of concurrency in a distributed way and with a nice shiny UI. But it's also expensive, so you get what you pay for. And then BlazeMeter is Apache JMeter in the cloud with a fancy website and some awesome reporting. So all these services will essentially do the same thing, which is like, how do I generate high levels of traffic against an application? Some of them are better for complex application interactions. Some of them are better for using real browsers versus just server HTTP requests, but your mileage may vary. So this part, I think a lot of people forget. It's great to understand how everything works when it's designed perfectly and there's plenty of resources available, but you should also understand how well does the application, the infrastructure, respond to failures. What happens if you lose a memcache cluster and database request spike or request spike to some backend? How well does the infrastructure handle that? What happens if at a certain level of concurrency, somebody rate limits you and all these HTTP connections start hanging? Do you try? Do you retry and exponentially back off? Do they just sit there and wait? Not all application problems are your fault. Oftentimes, it's a third-party service provider that's having an issue or something that you can't control. So you should test for those failures, or at least understand how the application responds when you are having failures. So if you're in if you use Amazon Web Service, Netflix has released a bunch of different tools called the Simian Army. One of those is the Chaos Monkey that can go through and wreak havoc on your AWS site, in your AWS infrastructure, like block ports and turn services off, et cetera, et cetera. So the idea here is what happens when things fail and how does the application respond. So don't just run everything under the best possible conditions, but figure out how to simulate common failures and see how you respond. I've had many production failures because some timeout was a little too long and everything hung for some reason, so it's easy to miss. So just to recap some best practices, treat performance as a feature, capacity plan and load test the server side, optimize and performance test the client side, understand your starting point, and more importantly, instrument everything. In order to understand the change between releases, whether it's a package upgrade, you move from MySQL 5 to 5.6, or you add a bunch of servers, you want to understand the relative performance impact, and you can't do that unless you know where you're starting from. And then monitor performance and development and production. If you only find out, when I asked earlier, I actually mean this seriously, most people don't monitor production performance, and the way they find out about business critical applications failing is somebody files a ticket, eventually somebody sees, oh yeah, nobody in Australia can access our website, that's probably a problem. Right? And you should be proactive about that. You shouldn't have to wait for the customers to complain to you. There's a lot of this stuff can be caught in development environments, and a lot can be, you should know about it early in production. And then measure the difference of every change, whether it's a new production deployment, a database upgrade, or just a new feature. You should understand the cost of that. And then automate everything. Again, I'm a pretty lazy engineer. I like to do things once and then just be able to run a script and do it again and again. And if I can, just automate it into the process. So those are really I think the biggest tips is automate performance testing as part of your build and deployment process. And more importantly, understand how failures impact performance. So don't just wait when things are successful. So again, integrate automated performance testing into your continuous integration setup. There's a ton of tools that make this very easy to do. All of the tools that I talked about can be automated. Understand the performance implication of every deployment and every package upgrade, every change. and more importantly, monitor the end user experience from end to end and production. And that is all I have for you guys. Any questions? Let's not go all at once. I know I went a little fast on that, but the slides are available on speakerdeck.com, speakerdeck.com/Dustin Whittle. In the slides, there are notes, so if you really want to understand how to follow each one of these things that I've said, there's a bunch of details and step-by-step tutorials in the notes. So if you have any questions, please feel free to reach out on Twitter or come see me at any point in the event. Thanks for joining.